Good day, everyone. So today we will be discussing about data warehousing. So in this particular topic, at the end of the discussion, we are expecting to define the different terms used in data warehousing, and we to be able to explore the reasons for information gap between information needs and availability, and you should be able to understand reasons for the need of data warehousing. Also, we are expected to describe the three levels of data warehouse architectures and describe the two components of star schema. You are also expected to estimate the fact table size. You should be able to design a data mart and develop requirements for a data mart. So let's go first to the data warehouse definition. So when you say data warehouse, it is a subject-oriented, integrated, time-variant, non-updatable collection of data used in support of management decision-making process. Basically, we can describe a data warehouse as a common repository or just a one big storage for all the data of the company that has been gathered or accumulated all throughout the years of its operations. So it contained data 10 years, 20 years ago or more. So basically, when you say data warehouse, it is subject oriented because it contains the data specific to customers, patients, students, products, suppliers, etc. And it is integrated because you should be having a consistent naming conventions for all your data being saved in the data warehouse. The format, integrated format may be from a database or from a flat file such as Word document or Excel. And it came from different sources. It can be from your database system, your file processing, or the flat files. Then a data warehouse is also time variant. So when you say time variant, it can give you trends. You can do forecasting and prediction as to the behavior of your organization or of your company. Example, you should be able to predict as to what product is saleable to the market, and you should be and if that particular in that particular product that is saleable in the market, which age bracket is the most what do you call this one, is the most patronized or mostly patronizing your product. So that's how you do trend analysis. So you can do when it's a time variant, you can do forecasting, analytics, and predictions, and so on and so forth. And it is also non-updatable. So when you say non-updatable, it's read only. So all the data in there, saved in the or yeah, stored or saved in the data warehouse, cannot be changed. It's read only. The purpose of it to be read only is to maintain its integrity and reliability. Okay. Now let's also define what data mart is. So when you say data mart, it is a subset of a data warehouse. It is somewhat like a data warehouse that is limited in scope. Kumbaga, it is analogous to a house. A house is your data warehouse. And each room in your house, like the living room, the kitchen, the dining, and the bedrooms, are what we call the data marts. So it's very specific in terms of domain or of its scope. So example, you can have a data mart for customers only. So all you have to do there is to record all the data pertaining to customers present in your warehouse. So basically, when you say data mart, all the data, all the data that can be used by the data mart are coming from the data warehouse repository. So let's go to the history leading to data warehousing. So you have your improvement in database technologies, especially in relational databases. So in relational databases, that it's more flexible. It's what they call this one. It's flexible, faster in processing. So advances also in computer hardware, including machine power architectures, and the emergence of end user computing with powerful interfaces and tools. So another reason is reason that leads to data warehousing is advances in middleware in enabling heterogeneous database connectivity. So meaning all these middleware, given that these middleware you can use different databases in your company or in your system. Even though you have multiple types of databases, just have this middleware to connect para maka-access ka in all those databases. And recognition of difference between operational and information systems. So why is there a need for data warehousing? So there is a need for integrated company-wide view of high-quality information that is disparate databases, meaning different databases. So company-wide view of high-quality information and separation of operational and informational systems and data that is for improved performance. So let us check this one by one. So let's cover the issues with company-wide view. When you say company-wide view, you should expect that it is inconsistent in key structures, synonymous in terms of attribute meaning convention, free form versus structured fields, inconsistent data values, and missing data. So this is an example of heterogeneous data. You have here the student data, student employee, and student health. So it refers all to student. So you have here the student number. So when you say student data, it talks about the student. Student employee, it talks about the student, or it holds the student information who are at the same time working. Right? Then you have here the health of each specific employee. So this is heterogeneous, meaning this is a combination of different data for student alone. So you have your organizational trends motivating data warehouses. So there is no single system of records, multiple systems not synchronized. Then you have organizational need to analyze activities in balanced ways, customer relationship management, and supplier relationship management. Now, let's try to differentiate operation, operational and informational systems. So when you say operational systems, it is a system that is used to run a business in real time based on current data and support system available. On the other hand, when you say informational system, it is a system designed to support decision making based on historical point in time and prediction of complex queries or data mining application. So when you say operational system, that is the current system being used in the company to perform their day-to-day transactions. On the other hand, when you say informational system, this is the type of system that management is using to derive information for them to be guided in their decision making as to what they will do for the company so that it can retain or it can be more efficient or it can give better service to its clients. So when it's informational systems, it can do data mining applications such as prediction of data or wisdom. So that's what we call the operational and resource informational systems. So let's go here for the comparison of operational and operational systems. We have here the characteristics and then characteristics of each operational of the two different systems, operational and informational system. So the primary purpose of operational system is to run the business in current basis, while on the other hand, for the operational system is to support managerial decisions for type of data, current representation of state of business, while information system is in historical data, snapshots and predictions. Primary users for operational systems, each registered clerks, salespersons, administrators. On the other hand, for the information systems, the primary users are the managers, business analysts, customers, etc. Scope of usage for operational systems, you have here narrow, planned, and simple updates and queries. While on informational systems, it's broad, it's ad hoc, complex queries, and analysis. Design goal for operational system, that is performance, that is throughput and availability. For informational system, its ease of flexible access and usage. In terms of volume, operational systems, there are many constant updates and queries on one or a few table rows. On the other hand, informational systems, periodic batch updates and queries running many or all rows. So you have here the data warehouse architecture. So inside your data warehouse architecture contains independent data mart. You also have here the dependent data mart and operational data structure. You also have what we call the logical data mart and real-time data warehouse. And we have the three-layer of architecture. All of these involve some form of extract, transform, and load, or what we call the ETL in data warehouse. So let's go first with the independent data mart warehousing or data warehousing architecture. So you have here your different data sources, your may it be internal database from your POS, from your storage, or from external platforms. It will be extracted from these sources. It will do the transformation. So E is for transformation. Then you have here for the processing, that is extraction, and how to categorize the data, cleaning the data, and then be able to know which data mart should be loaded. Then after the transformation part, you have here the loading of those processed data or transformed data into its respective data mart. So in the end user presentation tools, you have here the ad query tools, you have here the OLAP, and visualization tools and everything else. Okay. So this is for independent data. Or meaning, when you say independent data mart, each data mart data are coming from the different sources of your data. On the other hand, when you say dependent data mart, so all the data will be extracted from all the different sources, will then be processed and transformed accordingly. Then it will be loaded into the data warehouse. Then from that data warehouse, the data will then be classified and loaded to each data mart under this data warehouse. So these data marts, all the data are dependent or are coming from the enterprise data warehouse. So we call it dependent because it cannot extract its own data from the sources, but it can only extract or get the data from the enterprise data warehouse. Then that's the time that the user can access it. So we have here also the logical data mart with real-time warehouse architecture. So from your data sources, it will be transformed, it will be processed, cleaned, categorized, then it will be loaded to your real-time data warehouse. And you have to, from your real-time data warehouse, it will be transformed through the transformation layer and distributed to the different data mart accordingly. So that's a logical data mart in real-time terms. So we have here the comparison between a data warehouse and a data mart. So basically they differ in scope. So data warehouse is more general, while data mart is more specific. When you see when it comes to data, both are historical, but it's what we call this one for the data mart, it's highly denormalized. For subjects, data warehouse can have multiple subjects, while for the data mart, it's specific to one concern or one subject. For sources, you have many internal and external resources when it comes to data warehouse. For the data mart, you have few internal and few external sources. For other characteristics, data warehouse is flexible, while data mart is restricted. Data warehouse is data oriented, while data mart rather is project oriented. Data warehouse long file, data mart short file. Large file for data warehouse and smart file for small file for data mart. Single complex structure for data warehouse and multiple semi-complex structures with complex structures when it comes to data marts. So we have here the three-layer data architecture for data warehouse. You have here your enterprise data model. So this is the overall repository. So this is the main repository. You have your reconciled data. The reconciled data can also contain data from a metadata and also some relational data. You have to reconcile the data. Then you can, given the reconciled data, you can derive a data mart and produce metadata for that particular data. So you have here data characteristic status versus event data. When you say status, then you also have event. So status, you have here the different data K123, ABCDEF, birth date 7. Event withdrawal, meaning there is an update. So event here is the update. So what is the status after that event? So when you say event, it's a database action. That means it can either be create, update, or delete that results from a transaction. So when you say status, that is the current value of your database, the current state of your database, the current record it is holding. Once you do a transaction, you do an event such as update, insert, or delete. That's event. After the event, the result is the new status of your data. Okay. So we have here another example. We have table X with the date 1009, table X, date 1010, and table X at 1011. So if transient data changes to existing records are written over previous records, thus destroying the previous data content, meaning in every update, the update overrides the previous record, thus destroying the previous data content. So as you can see here, at table X dated 10/9, 10/9, you have here P004, column A value G, and column B value H. So once there is an update for 004, the update is it changed the value of column A from G to Y. So what happens when it comes to table X 1011, there is now no record existing for the key 004. So what happened now? Since wala na siya isulod, what happened? When it gives you the new status of your data, instead of having GH, you now have YH because you performed an update action here, update. U means update, C means create. So you have here, there is an update for column A changing G to Y. So the final status table of your of table X is now YH. Then there is an action D, meaning deletion. That is why you have here no entry for 004. So let's now go to other data where has changes. So new descriptive attributes, new business activity attributes, new classes of descriptive attributes. Descriptive attributes become more refined. Descriptive data are related to one another, the new source of data. So for the derived data, its objectives are ease of use for decision support, fast response to predefined user queries, customized data for particular target audiences. Then you have your ad hoc query support and data mining capabilities. The characteristics for this derived data, it's detailed, mostly periodic, aggregate, and distributed. So most common data model is the dimensional model, usually implemented as a star schema. So this is how a star schema looks like. You have the fact table, and there are multiple tables connected to the fact table. So you have your dimension table 1, dimension table 2, and so on and so forth. And each key attribute for each dimension table is a foreign key in the fact table. So this is how a star schema looks like. So let's have here an example of a star schema. You have here your fact table, which is the sales, and your dimension tables. You have product, period, and store. You know that it's the dimension table because it holds the primary key. And you know that it's a fact table because it holds there the primary key to be the foreign key of each dimension tables. So let's have here a star schema with sample data. So you have here the sales. You have here your product code, which is a foreign key, and its source table is the product dimension table. The period code is a foreign key with the source table period. And the store code is the primary key of the store table. So you have here the different data of your dimension tables connected through the primary key foreign key relationship to the sales table, which is the fact table. So if you wanted to access the detail for product code 110 and which store it is being displayed, all you have to do is to look at it in the product, in the sales table, and be able to perform a join with the store table so that you will know if that particular product is being sold in that particular store. So gamit lang mo tag join ani. Join is very helpful. So you can either perform the direct join. It can be left join, inner join, or right join. It depends on how you how you wanted your output to be. And what they call this one, you can also implement the through stored procedures, and inside your stored procedures is the join operation. It's better if you want to store to have it in a stored procedure. It's better because it will be easier for you to call the procedure than recreate the join operation. Okay, so that's how important joins are and stored procedures are. So when you say dimension table key should be surrogate. When you say surrogate, it's non-intelligent and non-business related. So these are business keys may change over because business keys may change over time, and surrogate keys helps keep track of non-key attribute values for a given production key. Surrogate keys are simpler and shorter, and surrogate keys can be same length and formal for all keys. So when you say grain or fact table, granularity of fact table, what level of detail do you want? So transactional grain for finest level, aggregate grain more summarized, and finer grains, that is better market-based analysis capability. Finer grain, more dimension tables, more rows in fact table. A web-based commerce finest granularity is a click. Then you have your duration of the database. Basically, the data that can be stored in the data warehouse, data mart. Natural duration is data with for the past 13 months or 5 quarters. Financial institutions may need longer durations, so that is greater than 5 quarters or greater than 2 years. Older data is more difficult to source and cleanse. Size of fact table. So it depends on the number of dimensions and the grain of the fact table. So when you compute the size of the fact table, that is number of rows is equal to the product of number of possible values for each dimension associated with the fact table. So you have here an example. So example, we have a star schema, the previous sample that we have. So total number of stores, 1,000, total number of products, 10,000, total number of periods, that is 24 months. So total rows calculated, total rows is equal to 1,000 stores times active products. Katong active na ginabaligya in these 1,000 stores times the number of months. So the size of fact table is now 120 million. So that's how big as your fact table is. Okay. So we have here modeling date. So fact tables contain time period data. So that this is what they call the date dimensions are important. So you have to be very careful or particular in dates. In your fact table, you have here the full date of the week. Then you have here the number in month, day number overall, and so on and so on. So these dates are very critical when you do forecasting or prediction analysis. Dates are very critical. So there are also variations of star schema. So you can have multiple fact tables and you can also have factless facts table. So when you say multiple facts table, it can improve performance, often used to store facts for different combinations of dimensions and conform dimensions. When you say factless facts table, you have here no non-key data, but foreign keys for associated dimensions and used for tracking events and inventory coverage. So we have here conform dimensions. So we have your conformed dimensions for fact tables. You have two fact tables here, the sales and the receipts. So as you can see, you have for what do you call this one? For sales, and the other one are for the products. So they, when you say conform, they are two connected star schemas, and they are connected through the product purchase and the sales product, because it is through the purchase product that you can sell. Diba? Kung sa imong ibaligya kung wala kay gipalit from the supplier. So diri sila nag-conform. Even though there is no line connecting between these two, it simply means that they use the same data. It's all about products. So this is two conform what do you call this one? Two conform, we call this two conform dimensions. So you can have multiple conform dimensions. Do not limit it to two dimensions. You can have two or more. You just have to identify as to which dimension they will be associated with. So in this case, it is for the product table. Particularly, there is a purchased product by the company, and that those purchased products are being sold by the company. Okay. So let's have here the fact plus fact table showing occurrence of an event. So you have here, when you say fact plus fact table, it only contains the foreign key or the primary keys of the dimension table. There are no other attributes for the attributes for exclusive for the fact table. So this is a factless fact table, meaning it only contains the primary key of the dimension tables involved in this particular star schema data mart. So that's different to this particular example. There's that. Here, as you can see, you have here the primary keys for the dimension table, and these are the fact table attributes. So that's totally different from the factless fact table. So it only the factless fact table only contains the dimension table's primary keys. Okay. So normalizing dimension tables. So you have multi-value dimensions. So facts qualified by a set of values for the same business subject. And normalization involves creating a table for an associative entity between dimensions. So the fact table is actually an associative entity coming or derived. When you recall, the fact table is an associative entity having been connected to the different dimensions involved in the star schema. So we have here the different hierarchies of normalizing dimension table. So sometimes a dimension forms a natural fixed depth hierarchy, and you also have the design options, which includes all information for each level in a single denormalized table, and normalize the dimension table into a nested set of one-to-many table relationships. So this is an example of multi-value dimension table. So you have here the fact table and you have your dimension table. As you can see, there is a connection between two dimension tables, which is the diagnosis and the helper table. So helper table is an associative entity that implements the many-to-many relationship between dimension and fact table. So this is what we call the fixed product hierarchy. So your product group, your category, product family, product dimension, and then you have your fact table. So dimension hierarchies have to provide levels of aggregation for users wanting summary information in a data warehouse. So that we also have a slowly changing dimension of SCD. How to maintain knowledge of the past. And we have different approaches. We have the Kimball's approach. Type 1 of Kimball's approach. You just have to replace old data with the new data. So you are going to take the risk of losing the historical data. Type 2 of Kimball's approach, you have for each changing attribute, you can create a current value field and several old value fields. That is multi-value. Type 3, create a new dimension table row each time the dimension object changes with all dimension characteristics at the time of change. This is the most common approach. Every time there are changes or in the table or in the dimension table, you have to create a new dimension table row to reflect those changes. So we have here an example of type 2 SCD customer dimension table. So type 2 is for each changing attribute, you can create a current value field and several old value fields. So we have here the customer table connected to the fact table with the date key and customer key. You have here the product key and metaverse. So for the customer table, we have the start key and the customer key. So the dimension table contains several records for the same customer. Then the specific customer record to use depends on the key and the date of the fact, which should be start and the end dates of the SCD customer table. So we have here dimension segmentation. For rapidly changing attributes, also known as hot attributes, type 2 SCD approach creates too many rows and too much redundant data. So in this case, you have to use segmented approach instead. So you have here your fact table, and then you segment the customer table into two. You have the constant details for customer, and you have here the hot or the rapid changing attributes, which includes the educational level, number of children, marital status, credit band, purchase band, and so on and so forth. So when you say hot, from time to time, its value of its value is changing over time. When you say permanent, called the slowly changing attributes. These are the values that may or may not change over time. So you just have to segment the customer table into two dimension tables. So you have 10 essential rules for dimension modeling. Number 1, you need to use atomic facts. Number 2, use atomic when you say use atomic facts, this cannot be subdivided, or this is the very simple form of facts. Then you can create single process fact tables, include a date dimension for each fact table, enforce consistent grain, disallow null keys in fact tables, honor hierarchies, decode dimension tables, use surrogate keys, conform dimensions, and balance requirements with actual data. So there are other data warehouses advances. Number 1, columnar databases. So the issue of big data that is unstructured volume of data. Columnar databases optimize storage for summary data of new columns. Then data compression, and then you have the C-base, Vertica, and InfoBrite technologies. Now there is no SQL, meaning not only SQL, deals with unstructured data, and it can be implemented using MongoDB, CoachDB, Apache, Cassandra. So the user interface metadata or the data class. It identifies objects of the data mart, identify dimensions and facts, indicate how data is derived from data warehouses, including derivation rules. So it also indicates how data is derived from operational data store, including derivation rules, identify available reports and predefined queries, And identify data analysis techniques, that is drill down analysis, identify responsible people. So we have here the online analytical processing tools, or what we call the OLAP. So the use of a set of graphical tools that provides users with multi-dimensional views of their data and allows them to analyze the data using simple windowing techniques. And we have the relational OLAP or roll-up. It's traditional relational representation. So multi-dimensional OLAP, you can consider it to be cube structured. In OLAP operation, you have here cube slicing, drill down operations. So cube slicing come up with 2D view of data, and drill down going from summary to more detailed views. So basically, when we do OLAP, we will be having a separate discussion about OLAP also. So slicing a data cube. So this is an example of the data cube. You have your products, you have your months, and your measures. So when you do slicing, you take one column, and when you do drill down, you go to the specific of those column. So example, I have the product shoes. So I slice the shoes from the product cube, and then I did drill down. So what, when I say drill down, what are the details for that shoes slice? So I have here the number of units, revenue, and cost, and I have here the months. So that this is what we call slicing data cube. You what they call this one? You take the slice and you get the details. For the drill down, you can now generate as to the details of this. So given the number, given the shoe type, how many of the shoe, that particular shoe type is being sold among the sold shoes, what size is the most saleable? That's example of drill down. Business performance management. So this is a dashboard of business performance management as to monitoring how the business performs over time. So is it going upwards or going downwards on trend? Upward, good, meaning your business is doing good. Kung downward, medyo delikado. Business is not doing well. So charts like this are examples of data visualization and the representation of data in graphical and multimedia forms for human analysis. So in this case, if you have these graphical or data visualization, it will really help your decision makers as to what action should be taken in order to mitigate the downward trends, and what actions should be maintained in order to support or to improve more for trends of the business. So this is just an introduction of what data mining is. So when you say data mining, it's knowledge discovery using a blend of statistical, artificial intelligence, and computer graphic techniques. Its goal is to explain observed events or conditions and confirm hypotheses and explore data for new or unexpected relationships. So you have different data mining techniques, regression, decision tree, clustering, affinity, neural networks, and so on and so forth. But anyways, when you say data mining, you will be encountering this one when you are going to choose the database track in your specialization. So there is a subject for data mining. So I think that's all. So I would like to thank you for watching and for listening. For questions or for some clarifications, just jot it down so that we can discuss it next meeting during our online class. Thank you and have a good day.